The art of cooking, the preparation of palatable and attractive food, depends upon a knowledge of procedures based upon results of laboratory studies. These studies explain certain scientific principles that concern the way in which heat is applied to foods by water, air, or steam to cook them, and the effect of the cooking process upon the palatability and the nutritive qualities of foods. To examine these principles, we first see what changes take place when heat is applied to food. Heat cooks foods such as vegetables and this whole grain cereal by penetrating the fibrous framework of the cell structure. Within each food cell, here shown greatly magnified, there are many starch granules. The heat penetrates the cell walls and causes the starch granules to swell and soften. The cell walls partially disintegrate under continued heat, and the starch particles swell further, some even bursting. Thus, the starch is made more easily digestible. This softening of cell fibers and swelling of starch granules is apparent in this steamed rice. Meat is cooked by action of heat on the muscle, fat, and connective tissues. Connective tissue causes toughness in some meats. Muscle tissue is made up of many groups of small elongated cells containing protein in solution. Groups of these cells, here seen in cross-section, are held together by connective tissue and connected with other muscles by it. Large and small deposits of fat are found around and embedded within these tissues. When heat is applied, the fat melts and aids in conducting heat through the other tissues. This heat coagulates the protein in muscle cells, making it more easily digestible. It also softens part of the tough white connective tissue, changing it to digestible gelatin. Thus, through cooking, meat is made more easily digestible and more appetizing. In the boiling process, food is cooked by direct contact with hot water. Through contact with water, however, soluble foodstuffs are likely to be lost. In the potato, for example, the greatest concentration of iron and vitamins is next to the skin. Most of the starch occurs in the outer part. Toward the center, the water content is higher and the food value lower. A minimum of peeling and cutting reduces the amount of surface exposed to water. Consequently, minerals, vitamins, and exposed starch are saved. Also, the use of as little water as possible helps to conserve soluble foodstuffs. After food is placed in the receptacle, the flame is lowered so that the water will boil quietly. This gentle boiling avoids breaking up and exposing more food surface by the rough action of vigorous boiling, and a tightly fitting cover reduces evaporation. All vegetables should boil only until they become tender and are yet firm, as revealed by a fork test. Minimum boiling also helps to retain food values. In the double boiler, water is used to convey heat by steam. The heat created in the lower part is transferred to and cooks food placed in the upper part. This arrangement provides a constant temperature somewhat below the boiling point of water, as some heat is lost as it is conveyed through the inner vessel. Here, a white sauce is being prepared. With low heat, there is no danger of scorching the food. The mixture thickens without lumping or curdling, and a smooth, velvety quality of sauce is obtained. In the steamer cooker, potatoes, carrots, and other vegetables may be cooked by direct heat from steam. This steam rises from the boiling water below and circulates through the food in the compartments above. In the pressure steam cooker, the lid is tightly clamped down, imprisoning steam and producing pressures. As a result, the water and steam temperatures in the cooker rise above the normal boiling point of 212 degrees Fahrenheit. High temperatures and pressure shorten cooking time. When this is finished, the steam is liberated and the pressure is reduced to zero so that the cover may be removed safely. Rapid cooking by steam under pressure kills bacteria that otherwise might not be destroyed and helps to conserve food values. A small pressure cooker is the most practical for home use. It operates on the same principle as the larger one, imprisoning steam under pressure. The combination of pressure and high temperature cooking tenderizes the fibers in tough cut meat more quickly than by other processes. Deep fat frying is a process used for preparing a limited number of foods in which a golden brown, crispy surface is desired. Flavorless fats, or those of mild flavor that can be heated to 400 degrees Fahrenheit or slightly above without smoking, are used. Foods such as these potatoes should be dried before being placed in hot fat. Foods that cannot be dried easily are dipped in egg mixture and then rolled in breadcrumbs. The egg protein will coagulate on being heated and form a protective coating. This coating helps prevent food from absorbing fat as it is fried. With less moisture on food surfaces, the high temperature fat can immediately conduct heat to the food. Another factor that helps prevent fat from entering is the resisting pressure created by steam generated within the cooking food. As soon as it is cooked, the food is removed from the pan and drained to prevent its absorbing fat on cooling. Pan frying in a small amount of fat is a method for cooking potato cakes, bacon and eggs, and small tender meat cuts. When using less fat, rapid hot frying below the smoke point is necessary, with immediate removal of food when done. Another method for cooking tender meats, such as young chickens, is by broiling. In this process, the food is cooked largely by direct heat from the flame. The greased broiling rack is placed under the flame at sufficient distance to avoid scorching before the food is properly done. Some vegetables may be cooked in the same way, being prepared as the meat broils. Only when the meat is about done on one side is salt added, because salt tends to draw out nutritive juices from uncooked meat. Now the chicken can be turned. A variety of foods may be prepared by broiling without the danger of absorbing indigestible grease or loss of nutritive value from contact with water. Those that cook quickly should be put in only when the meat is nearly done. For temperature control in oven cooking, a thermostat is commonly used. Or an oven thermometer will indicate the inside temperature. Cuts of meat that are too tough to roast may be slowly braised in the oven in a small amount of liquid, with or without vegetables. A cover prevents evaporation. The long, slow braising process is effective in making muscle tissue tender. While the meat is cooking, potatoes or other vegetables also may be baked alongside, retaining much flavor and nutritive value. Oven cookery is an economical means of preparing many kinds of food from a single heat source. Oven heat is also used for baking or roasting large cuts of meats. A meat thermometer, inserted into the raw meat before roasting, determines internal temperature or degree of doneness. Keeping oven temperature at a low to moderate heat helps retain juices and prevents meat shrinkage or loss of weight. Use of a roasting chart is advisable. For example, this 10-pound beef roast should cook at an oven temperature of from 300 to 350 degrees, from 22 to 25 minutes per pound, or about 3.5 to 4 hours. Thus, we have learned that there are several factors involved in cooking: the way in which heat is applied to food, the changes that take place during cooking, and the methods which best conserve nutritive values. These principles form the guiding basis for preparing nutritious, palatable, and attractive meals.